Ratti, who is the director of MIT's Senseable Cities Lab.
Thank you. Good morning, everybody. Great pleasure to be here with you today. And what I decided to do today, to share with you some of the work that's happening in this space when it actually intersects with cities and with the places we live in. But before that, just one example is almost as an analogy. If you look at this, that's a Formula One racing car. And something interesting has happened in Formula One racing over the past 10, 20 years. 10, 20 years ago, in order to win a race, you needed a good car and a good driver. The physical infrastructure was crucial. And today, you also need this, which is, again, an infrastructure collecting data from thousands of sensors onto the car, sending it to those computers where it's analyzed, it's processed, and decisions are made in real time. In other terms, for all of us with a background in engineering, that's a real-time control system. A system made of two components, a sensing component and an actuating component, collecting information from the car and responding to that information. Now, the amazing thing we believe today is that our cities are starting to behave a little bit like that Formula One racing car. Our cities are being covered, layered with many different types of sensor networks and so on. And so the way we get information from cities and we respond to that information is changing. Almost as if every atom out there were becoming potentially both a sensor and an actuator. So I want to share with you some examples taken especially from the field of urban mobility and how that is going to transform the places we live in. We know that the automobile has been the main driver of urbanism in the past century. Our cities have been built around the automobile. And today, perhaps, because of new mobility systems, our cities will change in a similar way to what happened around 100 years ago. If you look at that, that's a map of New York. Every dot tells you every taxi for a pickup or a drop-off. That's JFK Airport in New York. If you zoom out, you see Manhattan and all of the boroughs. We were down there. That's a map that we did with data that Mayor Bloomberg made public a few years ago, data from the Taxi and Limousine Commission. And so when you got all of this, then you can ask yourself, well, how many of those trips could be shared? Today, we like to share many things in our lives, apartments on Airbnb, couches, on couch surfing platforms. So how many trips we could share in New York? And if you look at those 2 points in Manhattan, you got hundreds of thousands of trips connecting those 2 points in the course of the year. So if you want to solve that question, you cannot do it with traditional mathematics. Sometimes we say that big data needs also big math or new type of mathematical approaches. So what we did here was look at something we call shareability networks, using network science in order to answer the question. Here you see these kind of shareability networks that densify. And if you phrase it mathematically like this, say, what is the minimum number of vehicles I need in order to take everybody to destination when they need to be there, give or take a couple of minutes, then these are the results. And what you see there at the top is quite striking, that in New York, you could actually cut 40% of the fleets we have today if people were ready to share and still take everybody to destination exactly when they need to be there. Now, two interesting things happened. The paper is from last year, but the first results came out earlier, and they came to the attention of Uber. Since then, we started a collaboration with Uber, and as you might know, Uber Pool does exactly this, allows two people to share the same ride. The other thing that happened is that when the results were published, the New York Times did an article on these results and said, well, these are interesting things, but no New Yorker would want to share anything else with another New Yorker, let alone a car. Well, it turns out that this was not the case. If you look at Uber Pool results, in San Francisco, I believe now they're above 50% of all trips. So it's really a very big impact on mobility. And every pool car means that you're removing one car from the street, which means less investment, less energy consumption, less pollution, and less congestion on the road. So that's just to show you about how data can help us to better understand the city and potentially also transform it. That's a follow-up paper from a couple of weeks ago where we actually looked at different cities and tried to find the universal shareability laws that really can tell you how this could be replicated not only in New York and in larger cities, but really in cities all around the world. Now, the other thing that is happening today in the space of mobility is that the car itself is becoming almost like a computer on wheels. And that's actually, what you see on this slide is exactly real-time data captured from a vehicle. It's a Volkswagen vehicle. Most vehicles today have a few thousand sensors that record everything that happens on the vehicle. Not only the temperature outside, the engine, every time you open the window, every time you turn on the wipers. And what we are doing here is actually using all of this in order to better understand the city. Imagine it's like, thousands of times more data than what your phone is collecting, but actually collected by the vehicle, and you could analyze it to better understand both the driver and also the city around. Now, take it one step further, and then you get these additional two sensors, the two little ears you see over there. They're a bit like the human eye. They do a three-dimensional scan of the city. You can do it with LiDAR or with cameras, but you get something like this, and then you feed this into an artificial intelligence system, and the car drives itself. Now, the amazing thing when the car drives itself is not the fact that you don't need to keep your hands on the steering wheel. The amazing thing is that the car can give you a lift in the morning when you go to your office, and then can give a lift to somebody else in your family or to anybody else in the city. So what you're doing, you're creating a new system in between public and private transportation. Now, if you combine this about the sharing of the vehicle with what I was saying before about the sharing of the ride itself, the combination of both could make a city such as Austin or New York or Singapore or London or Vienna, a big city or a small city, where you could take everybody to destination when they need to be there with just 20% of the vehicles we have today. Now, I'm not saying this is going to happen. It will depend on many different things, including regulations and policies. But basically, theoretically, today the car is really inefficient. It's used 5% of the time, and in that 5%, it's usually used by 1.3 people out of 5 seats. So if we can actually make that, thanks to real-time information, more efficient, then that can be a big deal. And I think that was the kind of many trillion-dollar industry we heard about before in the previous presentation by Qualcomm that could be changed and revolutionized by changes in mobility today. Now, when everything will be self-driving, then a few years from now, other things might change, such as this. Well, that's a well-known traffic light. And as you might know, traffic lights came on our streets when actually cars arrived on our streets. But if you've got an intelligent system where every car knows where it is and where other cars are, then you can think about different ways to manage intersection. Something like this. Don't try it yet. I gave a presentation a few months ago in Naples, and they told me, so what is new here? That's a quote from an Italian minister who said in Milan, traffic lights are instructions. In Rome, they are suggestions. In Naples, they are Christmas decorations. So again, we're doing quite a bit of work on this from a mathematical point of view, looking at the intersection and seeing how we can model it. What you see here is actually some of, intersection seems simple, but you've got different frequencies of arrival and different paths through the intersection. So here what you see is actually a real intersection in Singapore. To the left and to the right, you got the same amount of cars getting there, but to the left, managed with the most sophisticated traffic light system we have today, and to the right, actually managed with a slot-based system, similar to what you have in airports. All other parameters are the same in terms of safety for the intersection and so on. And look at the difference. Just after a few minutes, in terms of number of cars waiting and delays that you generate to the left and to the right. Now, the interesting thing as well is that an intersection is usually the bottleneck. You've got two competing flows fighting for the same real estate. So if you can fix the intersection, then those effects will trickle down across the whole city, across the whole network. We are looking at self-driving also in other contexts, such as the impact they have on the city. So if you do this, most likely we will need much less parking space in the city. And so, for instance, this is a design project we're doing right now where we're looking at the parking space, where we're putting a distance between the slabs higher. We're putting the ramps on the side so that space could be turned into other things in the future. So it becomes like an exciting space when maybe probably we will need much less parking spaces. Then at that point, we can reuse the infrastructure we built today for doing other things, such as this. And then also other ways of looking at self-driving. That's a project we started a few months ago in the city of Amsterdam. And, the city of Amsterdam is an amazing city, but not many roads in the city center, but a lot of canals. So we started thinking about, can we look at the self-driving boats? We could use them for moving people or moving goods in the city, for sensing water and sensing the city with all this kind of LiDAR going around, but also maybe to do like a responsive, flexible infrastructure for the city. Imagine a bridge that self-assembles when you need it, or a floating stage for a concert, or anything else you can need for a special event or for an emergency. So the idea that these things would come together, which is nothing new, it's what Venice has been doing for a long time, with all the gondolas coming together for a temporary bridge. But today we can do it in a different way thanks to technology. And one of the things we're doing is actually look at the little boats, almost like quadcopters. As you might know, in drones have become so popular because a quadcopter is very simple to build and to control. So we started thinking, can we do something similar from the point of view of the boat with 4 motors, either like this, 4 propellers orthogonal to each other, or something like this with water jets. And then when you combine it, that was just a couple of weeks ago in Amsterdam, a scale model of the project. You get something which is, can really be controlled in a very, very precise way. See another video here. You can also move laterally. In the worst case, we will develop a toy company. Everybody seems to love the way this works. And I wanted to finish with the following. Again, that's a project, actually, I added this project just a moment ago when I was listening to Qualcomm's presentation. It's a project we started with Qualcomm. And it's a project where a few years ago we asked ourselves, today we know everything about products. We know every chip, for instance, in this computer. We know where it was produced, how it moved on the planet, how it became that machine. Today we know where things are coming from, but we don't know where they go. Take that computer, in a few years from now, you will sell it to somebody. At some point, it will be thrown away. And then you know very little about it. Sometimes this is what happens today. A lot of e-waste from the United States being shipped illegally to Africa, from Europe to Asia. So our idea was, what if we could develop a little chip to put on waste and start tracking waste? It's almost like designing a miniature cell phone that needs to do a very simple thing, just get location and report back location over a cellular network. So we did this with Qualcomm. Those were some of the initial tests that we were doing. Here was the first deployment we did in the city of Seattle. We had 500 volunteers, came with 3,000 pieces of trash, put a little tag on all of them, e-waste, but also banana peels. I think, somehow you can think about this as the ultimate condition of IoT, when even garbage has, can be tracked and has, can be connected. So that was putting all the tags, and then here was the tracking system. So we started the day of deployment in Seattle, 3,000 objects. After a few days, you see some of the main landfills next to Seattle. But then a big surprise, how far stuff started to travel. Sometimes in crazy, unpredictable ways. Look at a trace that went all the way to Chicago and then changed its mind and went back to California. And still moving after 1 month and 2 months. We thought the Farewell Symphony was the right music. So what can you do with this? The first thing you can do is actually learn a lot about this system. It's not about the supply chain. You could call it like the removal chain. And then you can make it more efficient. Over the past few decades, we made our supply chain much more efficient. So here's a way we can actually apply the same thinking in order to streamline the way we move things around after they've ended their kind of basic normal life and become waste. If you look at that, we've done a few papers. There's really a huge amount of value we could actually capture if we were able to make those traces much more efficient to streamline all of this system of waste management on the planet. The second thing that's very important is that actually data itself, so the data you generate, if you share it with people, per se, can actually provoke very important change. Data means that we know much more about the city we live in, we know much more about the consequences of what we do, and so we can change our behavior. So we were sharing the data with all the volunteers, and then we went to them and got back to them and asked them about, how did this have an impact on your life? And we learned very important things, very interesting things. Data per se can actually help us to better understand the consequences of what we do, and hence, as I was saying, our behavior. Somebody came to us at the end and said, look, I used to drink water in plastic bottles every day and then throw them away and forget about them. But now, after the project, I know that those bottles go a few miles from home, they will go to a landfill, they will stay there forever, so I stopped drinking water in plastic bottles. So this idea really that behavioral change can be enacted by data. The third thing we discovered is that a lot of stuff would end up in ports and then disappear. And so over the past couple of years, we've been working on one of the largest ever done e-waste tracking projects, where we discover places such as this one in the middle of the jungle in Asia, and many other places. Some of these are legal, some of these are illegal. This is the shipment of e-waste from the United States to all over the world. Some of those traces, you can find all the traces on our website. If you're interested in it, also PBS, the TV channel, went to follow some of them and did a special on the project. But this was made public just a few months ago. And basically the idea that big data can tell us much more about global flows. And from global flows, we can then help take action and hopefully improve what is happening today. Again, some of these traces are legal, but some of them are not. And that's all e-waste from the United States being shipped to Asia and to other parts of the world. Now, the final thing we discovered was totally unexpected. And that happened when a burglar came to our offices at MIT. And the poor guy stole a lot of things, including tags and computers that tell you where they go. And this is what happened. All right, thank you.
You've got time for one or two questions here.
Yes. Yes.
Yes, I have a question. It's very interesting, the data you present, and they're very useful. What role do you see that the cities and the government has? And do we need to have a discussion in terms of what is that we allow to track it now? Because it might be good, but we might not like it.
Yeah, great question. I will repeat it. It's about, first of all, the role of governments, and then should we have a discussion about what type of data we use and what we don't. And then about the role of government, I think, in general, I think that in this space of urban innovation, governments shouldn't have a proactive role. So in this space of urban innovation, I think government primarily should actually allow many actors, many startups to play a role in this. Think about what's happening with mobility, with Uber, Lyft, and many, many other players today, with self-driving as well, with a lot of, we're really a rich innovation ecosystem. I think, the role of government in general should be just to promote innovation in society. Government can play a more direct role in a few fields, and those are usually when you think about municipal services. So if you think about, government, usually, yes, they have responsibility for waste, for water, for a few other things in the city, and there, they can actually be more hands-on. But I think in general, I think they should just try to promote a good environment so that innovation can flourish. Now, even that requires quite a lot of things. As we are seeing right now, it was mentioned before about, what's happening with self-driving, creating the good regulatory framework in order to allow people to experiment. That's a very important role that government can play. Regarding the second part of the question is about data. You're totally right. Now, I'm not too concerned about data here in the city, but yes, if you think about, all the data that you're leaving when you're going online, when you're going on Facebook, you're using your smartphone and so on, there's certainly a big discussion to have on data. Now, it's probably too difficult to address all the aspects of it right now, but I want to tell you that at MIT, we've done twice already a big conference called Engaging Data, where we had industry, we had the Obama administration, we had privacy advocates, academics, and so on, in order really to talk about that. How do we engage data? Because that's really a crucial question for society today, and that will shape the type of society we will live in tomorrow. So I think it's a very important point. Again, I don't think it's, I think it's primarily a political question, and I don't think it's particularly cities are important in this ecosystem, but there's something much more important, which is all the private data that we are, all the private fingerprints we are basically leaving every time we do something online today.
Great. Well, thank you very much, Carlo. We appreciate that. It was a great presentation, and unfortunately, we have to keep it going, so we don't have time for more questions, but we've got a coffee break coming up. Thank you so much, Carlo. All right, next up, we've got our first panel discussion of the day. This is focused on digital transformation, so join me in welcoming James Brim, who is the